Alright, welcome to 8th grade honors class. Now this class is designed to take 8th grade concepts and put it on a higher level thinking. So we're still doing 8th grade concepts, so most of our notes will be 8th grade. You'll receive like the algebra stuff when you get in class. But here we go, 8th grade honors class. We're going to start in a different spot than usual. We're going to start with similarity transformations. Basically transformations, you think of transformers. They change shapes and all kinds of stuff, and that's what we're doing. We're changing shapes. So the first definition for us is a dilation. Now every time somebody thinks of dilation, they think of getting smaller, or their eyes are dilated or something like that. Well, dilation is not just getting smaller, it's not just getting larger, it's both. It is a transformation in which a figure and its image are similar. So in other words, you're taking the same shape and making it smaller, or you're taking the same shape and making it bigger. Now, all the sides have to change, all the points have to change, the area changes, the volume changes, all on the same scale, because it has to be similar. If one side changes and the other side doesn't, then you're going to get a different shape. So everything has to change at the same time. So what that's called, the way it changes, is a scale factor. It changes by a scale factor. That means you're either going to multiply every side by the same amount, or every point by the same amount, or you're going to divide every point by the same amount, but it's a scale factor. It's the same amount. And it's the actual definition is the ratio in which an object is dilated, in which it changes. So here's an example. We have two triangles. One's a blue one and one's a red one. Now, as you can see right here, the original one is just an A, C, and B. Here's the original, here's an original, and here's an original. There's not a prime. This little prime right here is talking about this is not an original one, it's the new object that we're creating after we introduced a scale factor. Okay, so here's another prime and here's another prime. As you can see, this point right here does not change. So because it doesn't change, these two are the same. The original and the new are the same. Now all the other points change, so they don't have the equal sign with them. Alright. So, this one, the A, now that we're over here, the AC is 16. That means it goes from here, oops, sorry, wrong deal, from here to here. That's 16. That's this 8 and this 8 put together. And then AB goes from here to here. That's this point, this measurement, and this measurement put together. Now those are the only two measurements we have, and that's all we really need. So let's look at A prime and C prime. A prime and C prime and A prime and B prime. So A prime and C prime are just 8. And A prime and B prime are just 6. So we write all that down. Now how do we get from this one to this one? Oh, I'm sorry. From this one to this one. You have to divide by 2. But we want to multiply. We really just want to multiply scale factors. So what am I multiplying by? Multiplying by half. So my scale factor is a half. But let's check it out with the other one. How do I go from here to here? You divide by 2 or you multiply by a half. So my scale factor is a half. We checked it out. So we'll talk about area and volume later. But this is where we're just doing sides and points right now. Let's go on. Alright, there's two types of dilations. There's an enlargement and a reduction. Enlargement is getting bigger. Reduction is getting smaller. But a little bit more detailed. the scale factor for an enlargement, to get bigger, you're going to multiply it by more than 1. Because if you multiply it by 1, you just get the same thing back, right? If you multiply it by less than 1, then you're dividing, basically. So if you're multiplying by more than 1, you're getting an enlargement. You're making it bigger. If you divide by, or if you multiply by less than 1, you're making it get smaller. So it's a reduction. All right, last example. We're going to multiply the coordinates by 3 over 2. So is this enlargement or reduction? Yeah, it's an enlargement because 3 over 2 is more than 1. Alright, so let's check this out. Not only can we do the sides of an object, but we can also do the points. The individual points themselves, especially if they're on like a coordinate grid. So here we go. Let me change colors here. Alright, so we're going to take each one of these points and multiply them by 3 over 2. So let's check it out. Let me get my parentheses going here. What's negative 4 times 3 over 2? Top times top, bottom times bottom. And so what's negative 12 divided by negative 2? It's negative 6. Alright. Now let's do the next one. Negative 1 times 3 over 2. Well, if I just multiply by 1, it stays the same. So all we're doing is multiplying it by negative 1, so it's negative 3 over 2. So let's go to the next one. Negative 2 times 3 over 2. You get negative 6 over 2. You divide that, you get negative 3. And then again, it's by 1, so it's 3 over 2. 1 over 1 is 3 over 2 and 3 over 2. And here we have 3 over 2 and negative 3 over 2. Alright. Now that we've done that, we've made an enlargement. We don't even have to graph it. Now we have to name these points now. This is K prime. This is now L prime. This is now M prime and N prime. So, let's check this out real fast. Alright, so I transferred it over to a graph. Here we have our prime numbers, our new points, right here. So I'm going to go ahead and graph our new points. Let's see, so we have K prime, which is, alright, so I have our original object up there with LMKN, or KLMN. So what we're going to do now is graph this. We're going to graph our enlargement. So let's see if it's an actual enlargement. Let's check it out. So we have negative 6, negative 3 over 2. So negative 6, 1, 2, 3, 4, 5, 6. Here's 6 right there. And we want to get to negative 3 over 2. So what actually is that? That's 1 and 1/2. So we're just going to go 1 and 1/2. So let's check it out. We got 1, 2, 3, 4, 5, 6, and then 1 and 1/2. So it's right here. Alright, so now let's do the other one. Negative 3. So we're going to do negative 3 and 3 over 2. So negative 3, 1, 2, 3, and up 1 and 1/2. So there's my point. And then we're going to do 1 and 1/2 positive. So to the right here. So it's going to be right there. That's about a half. Now it doesn't have to be perfect, just close enough. And then up 1 1/2. So about right here, right at the M. And then last one, 1 1/2, and then down 1 1/2. So right at the end. So what I'm going to do is I'm going to go ahead and erase the old letters because they're kind of right in the way. So we're right here and right here. Erase these old letters because we already know what that is. And now I'm going to connect these lines with our new graph. So is that an enlargement or reduction? It's an enlargement. Now let's check this out. One quick last point. I know this one's an 11-minute video. Probably going to be 13 by the time I'm done, but we're almost done. I want to show you something. How did we get this new figure? We multiplied every point, every one of these points, measurements, by the scale factor. Well, why does that work? The reason why that works is because every one of these, like the -6, represents a side in the measurement of that side. Now, it's not a whole side, but it's a measurement of from here to here. And then we also measure 3/2, which is from here to here. And we multiply the combination of those two by the same scale factor. So let's see if it actually works on the sides. Let's measure the sides. Let's measure, try to find an easy one. Let's do this one to this one. How far is that? Let's see, that's -6, so 7 1/2. So that's 7 1/2. Now let's measure. So we have 7 1/2. Now let's measure from here to here. That's 1, 2, 3, 4, 5 1/2. Was that half? No, it's just 5. So it goes 1, 2, 3, 4, 5. The measure of that's 5. So how do we get from 7 1/2 to 5? Well, let's check it out. If we're doing enlargement, we take the original and we multiply it by 3/2. So we have to change 5 into a fraction. Top times top, bottom times bottom. What is 15 divided by 2? It's 7.5 or 7 1/2. So it works, and it works on every one of these sides, which is cool. So that's the end of our lessons for today. And I'll see y'all tomorrow in class.